not part of the course this year, but an important introduction to what is on the course are discrete random variables. So we'll quickly go through them and I'll give you a crash course in them, and then we'll explore one very specific type of discrete random variable. So what is a discrete variable, first of all? It can only take certain values and no values in between. Like it's either there or it's not there, basically. So it's often countable, number of heads when a coin is tossed 3 times. So it's either going to be 0, 1, 2, or 3, and nothing in between those values. So you can't get a half a head. Okay, that doesn't work. It's either 0 heads, 1 head, 2 heads, or 3 heads. Number of red cars on the road. It's either a red car or it's not a red car. So 0, 1, 2, 3, 100, 5,000, whatever it is. Discrete variables generally deal with number or size. And note that these values do not need to be whole numbers. So the thing that you're counting can be actually a decimal. Okay, so discrete random variables are random as its value is determined by the outcome of an experiment. So the result we get is determined by an experiment. Okay, and like a coin toss where we're counting the number of heads would be the result of an experiment. Or dice rolls. Random variables are expressed as capital letters. Okay, so X is usually the most common one, Y and Z, but it can be A, C, and the value that they can take on is by a lowercase, and they match up. Okay, so the lowercase x will be paired up with the X, the Y, and the Z. Okay, so the random variable is capital X. The value it can take on is lowercase x. We do usually look at another type of random variable called a continuous random variable, but that's in chapter 15 and deal with quantities that can be measured such as mass, height, or time. But this year they've removed it from the course. So let's have a look at an example. Let x represent the number of tails obtained in 3 tosses. We've got a head, tail, head, tail, head, tail, head, tail, head, tail, head, tail, or head, tail. Sample space, X could be. So these are the things that could happen. We've got head, 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 tail, head, tail, head, head, tail, tail. That's that branch done. Tail, head, head, tail, head, tail, 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 head, tail, tail, tail. Right, so that's what could possibly happen as a result of this experiment. So complete the table below which displays the values the discrete random variable can assume and the corresponding probabilities. So the random variable is x, x being the number of heads, or tails rather, obtained in 3 tosses. All right, so how many different ways, or what's the probability that we get 0 heads? Probability of the random variable being lowercase x, or in this case 0. Well, the chance of getting 0 tails means that basically it's all heads, and there's the only option. It's 1 out of 8. Okay, now it's 1. That's what is the chance that the random variable will be 1 tail. So let's have a look at that. There's 1 tail, and 1 tail. 3 out of 8. 2 tails. That, and that. 3 out of 8. 3 tails or all tails, 1 out of 8. Really crucial that you understand what that actually is saying. So what is capital X, denoted a random variable, in this case the number of tails obtained in 3 tosses, and lowercase x, the value which the random variable could take. So x could be 0 tails, 1 tail, 2 tails, or 3 tails. Thus the probability can be denoted probability of x, the random variable, equals lowercase x. The probability of the random variable is also a function of the value which the random variable can take. So this value here is a function of x, okay, because the value that you get here depends on what x actually is, whether it's 0, 1, 2, 3. Okay, so we actually can write that as a function, p of x. Okay, so p of x, this thing here, is another way of writing this particular statement here. Okay, because the probability that you get is a function of the x value. So what does PRX equal to mean? Okay, so that means what is the prob that the random variable x number of tails, let's have a look exactly what it's written, in 3 tosses is 2. Okay, and so that there can be answered with the statement 3 out of 8. The probability that the random variable x, number of tails in 3 tosses, is equal to 2 is 3 in 8. Let's have a quick look then at where it would appear in a VCAR exam. You're not going to see it like this, but this is a possibility. So we've got here the number of pets is the random variable. Okay, so and we're saying that it can assume one of 4 values: 0 pets, 1 pet, 2 pets, or 3 pets. And the probability that a student in a particular school has 0 pets is 0.5, or 50% chance. Okay, 1 pet, 25%, 2 pets, 20%, 3 pets, 5%. 5%. So close inspection of the table above shows some important characteristics which satisfy all discrete probability distributions. So again, I know I'm talking about a part of the course that's not relevant, but we do cover a particular type of discrete probability distribution, so it's important that we have a look at it. So the value of p of x, that's this here, is greater than or equal to 0, that's important, could be equal to 0, and less than or equal to 1. Okay, for every value of x. That is, that these values here can be 0, or can be 1, or can be numbers in between. But the exception is that when you add them all together, they have to equal 1. All right, so just say for argument's sake, this one here was certain. It was absolutely certain in the school that every student in the school had 3 pets. That would mean that all of these other ones would have to be 0. Okay, so 1 is a very rare thing to see. Okay, but you might get a table with a situation where one of the values is actually 0. So that could actually be 0. 1 pet is 0 chance, etc., depending on the school, stuff like that. All right, to determine the probability that x takes a value from the interval a to b, including the values a and b, then all we do is we add those things together. So what's the chance of having a pet in this school? Well, it's going to be that plus that plus that. We add together the values here between 1 and 3. We can also graph discrete random variables. Okay, so if this is our probability distribution, here we've got the value of x being 0, the random variable we can take on is 0, 1, 2, or 3, and these are the probabilities associated with it. We can actually put these values in on a Cartesian plane so that we can view what the graph might look like. Now notice that we're not allowed to actually draw a curve. I can't curve over the top of this, because that implies that 2.5 equals that value or 1.5 equals that value, and it's not true. It's either 0, 1, or 2. So I only put these dots in. I have seen these dotted lines drawn in. I tend not to do them, but you can. Okay, that's all I'm going to cover from 13C. So now we're going to head over to 14A.